Now in complex analytic functions, we'll be looking at gate questions. Before that, please like, share and subscribe this particular channel and click on bell icon to get a new notification. Let us start now. Now come next question. The question is, if x is equal to root minus 1, the one value of an x bar x is, they're asking, right? Now given that x is equal to root minus 1 and we have to find the value of x bar x is equal to how much, right? Now root minus 1 is nothing but I, so x is equal to nothing but I. So we have to find the value of I per I. That is how much, right? The general thing that we know is nothing but e per I theta is equal to cos theta plus I sin theta, right? Now we have to get the value of I only, so we consider e per I pi by 2. Then we get cos pi by 2 is nothing but 0 plus I sin pi by 2 is 1, so it do 1, which is equal to I. So we can consider I is equal to nothing but e per I pi by 2, right? When you apply log for both of them, then log of I is equal to I pi by 2, right? But you have to find the value of I per I. If you consider y is equal to I per I, then log of y is equal to I into log of I, right? We know log of I is equal to I pi by 2, so it becomes log of y is equal to I into I pi by 2. I multiplied, so it becomes minus pi by 2. It's not one log of y, right? So y is equal to nothing but it becomes e power minus pi by 2. Y is nothing but I power I. It's nothing but x power x. So answer the option. Coming next question. The question is, if phi of x comma y and psi of x comma y are function within a continuous second derivative, then phi of x comma y plus I of psi of x comma y can be expressed as an analytic function of x plus iy. As we know, the I is not one root minus 1, but for this one you have to know the Cauchy-Riemann equation. As you know that if a function f of z is equal to u plus iv is analytic, okay, where z is equal to nothing but x plus iy. The conditions are given as du by dx should be equal to dv by dy, and the other one is du by dy should be equal to minus of dv by dx. Now instead of using u and v, they given the phi and psi, right? So which is equal to phi plus I psi they given. So in the option, if you see it, it got satisfied in the option B, right? So if you consider the phi as an u, this is nothing but v, and this is u, this is v, it got satisfied. Now come to the next question. The question is, an analytic function of a complex variable z is equal to x plus iy is expressed as f of z is equal to u plus iv, where u and v is a function of x and y, where I is equal to root minus 1. If u is equal to xy, then expressed of an v should be. So they given that u is equal to x into y. Now you have to find the value of an v is how much, right? Now what we do is nothing but differentiate v. Then we get dv by dx into dx plus dv by dy into dy. But we know the CR equation, Riemann equation, right? That du by dx is equal to dv by dy. The other one is du by dy is equal to minus of dv by dx. So here we don't know the value of an v, we know the value of an u. So we are substituting here, get dv by dx is equal to minus of du by dy into dx plus dv by dy is du by dx into dy. Now we'll be differentiating this particular thing, okay? Now it becomes du by dx is equal to, it becomes y, and du by dy is equal to x. So substitute here, get minus of x dx plus y into dy is nothing but dv. Now it will be integrating, okay, the whole terms. And we get which is equal to v is equal to, it becomes minus x square by 2 plus y square by 2 plus constant term c, which is equal to y square minus x square by 2 plus c. C is the constant term, but they are k. So if you consider this term as an k only, okay. So answer will be option C. Now come next question. The question is the modulus of a complex number 3 plus 4i by 1 minus 2i is, okay. Now they given the function 3 plus 4i by 1 minus 2i, right? And you have to find the modulus of it, right? First what you do is nothing but multiply the top and bottom with 1 plus 2i. Then we get 3 plus 4i into 1 plus 2i by 1 minus 2i into 1 plus 2i, which is equal to, it becomes 3 plus 6i plus 4i minus 8 by, here it becomes 1 plus 4, which is equal to minus 5 plus 10i by 5, right? We have to find the modulus of this, which is equal to, it becomes under root of 5 as a 25 plus 100 by 5, which is equal to root of 125 by 5. If you bring pi under root, so it becomes under root of 125 by 25, right? Because one side goes 5 side, which is equal to root 5. So answer option B. Come next question. The question is, for analytic function f of x plus iy is equal to u of x comma y plus I of v of x comma y. U is given by u is equal to 3x square minus 3y square. The expression of an v. Okay. Consider that k is in a constant term. Okay. Now they are given the value of an e, which is equal to 3x square minus 3y square. Now we have to consider the y value. That's how much, right? As we know, dv is equal to nothing but dv by dx into dx plus dv by dy into dy by using a Cauchy's Riemann equation. Okay, we know that dv is equal to dv by dx is equal to minus of du by dy into dx plus dv by dy is du by dx into dy, right? Here we're defining the values of it. Du by dx, it becomes 6x, right? And du by dy, it becomes minus 6y. Substitute here, here it becomes minus of, this one is minus 6y into dx plus du by dy is 6x into dy is equal to nothing but dv. We'll be integrating it to get the actual value. Then you get v is equal to 6xy plus, here x term should not be there. Okay, remember, x term should not be there. Okay, then it becomes nothing but 0. So plus 0 plus k. So we have v is equal to 6xy plus k. So it goes with the option D. Now come next question. The question is, the analytic function f of z is equal to z minus 1 by z square plus 4 have singularity set. Okay, what are singularities? We have two types, isolated and non-isolated singularities. And in isolated singularity we have poles, removable singularity and essential singularity. Now in this particular case we can go with an poles. So they are given that f of z is equal to z minus 1 by z square plus 1. When this particular term becomes 0, it is not defined. It becomes nothing but not analytic. So we can say that when z square plus 1 is equal to 0, then we get z is equal to plus or minus root minus 1, which is equal to plus or minus I. It becomes a singularity poles, right? So you can see the option, it goes with the option D. Now come next question. The question is, which of the following is not true for the complex number z1 and z2, right? Now we'll be going with the options. If you consider z1 is equal to 2 plus I and z2 is equal to 1 plus I. Now we'll be going with an option. In option A, it is given as z1 by z2, right? So we can write this one as 2 plus I by 1 plus I. When you multiply both the sides with 1 minus I by 1 minus I, right? So which is equal to, it becomes 2 plus I is nothing but z1 into 1 minus I is z2 bar by 1 plus I into 1 minus I is nothing but mod of z2 whole square, right? So option A got satisfied. Now coming to option B, it is given as mod of z1 plus z2. When you add both of them, it becomes mod of 3 plus 2y, right? So find the mod of it, it becomes root of 9 plus 4, which is equal to root 13, which is equal to 3.06, right? Now defining the mod z1 plus mod z2, okay, and it becomes nothing but, here it becomes root 2 to the 4 plus 1, it becomes root 5 plus root of 1 plus 1, it becomes 2, right? Now root 5 is nothing but 2.23 plus root 2 is nothing but 1.4, which is equal to 3.64, right? So we can see that 3.06 is less than 3.64, so it got satisfied. Now coming to option C, mod of z1 minus z2, right? When you subtract both of them, it becomes nothing but mod of 1 only, which is equal to 1, right? Now we'll find the value of mod of z1 minus mod of z2, right? So which is equal to root 5 minus root 2, right? So subtract both of them, we get as 0.82, right? So 1 is less than or equal to 0.82, it does not got satisfied. It is greater than or equal to it comes. So option C is wrong. So coming to option D, mod of z1 plus z2 whole square plus mod of z1 minus z2 whole square. z1 plus z2 whole square, we get as nothing but 13 plus z1 minus z2 mod whole square is nothing but 1, which is equal to 14, right? Now defining for 2 into mod of z1 whole square plus 2 times of mod of z2 whole square. So 2 into mod of z1 whole square is nothing but 5 plus 2 into 2, which is equal to 10 plus 4, which is equal to 14. So it is nothing but equal to, right? In some cases it will be less than also. So option D also got satisfied. So answer is nothing but option C. Now come next question. The question is, the plot Z has been plotted in the complex plane as shown in the figure below. Okay, so they are given a graph here. This is a real part of an Z and imaginary part of a Z. If you consider this as x-axis, this is a y-axis, then it becomes minus x, this minus y, right? It is a unit circle, so this is nothing but 1, this is minus 1, this is minus I, and this is plus I, right? Now z0 is inside the circle. Now they are asking the plot of a complex function y is equal to 1 by z. You have to find for y where the graph would be coming for an y0. Okay. Now if you consider z is equal to x plus iy. Okay. Then we get y is equal to 1 by z. which is equal to 1 by x plus iy, right? When you multiply with x minus iy by x minus iy, then you get y is equal to nothing but x minus iy by x square plus y square. Consider this particular term as a constant term, x square plus y square. So which is equal to 1 by k into x minus iy. When you plot in a graph, it will be there in x-axis and minus y-axis. So it will be coming under the fourth quarter. So minus y and x. So in the option you can see that in option A and option D, y naught is coming in the fourth quarter, right? So it is coming in this minus y and this is x. And here also this minus y and this is x. Y not coming here. Now we'll be finding out whether it will be inside the circle or outside the circle. Okay. Now if you consider z naught is equal to something like 1 by 4 plus I by 4. Okay. Now we can point it out that it will be inside the circle, right? Now find the value of an y, which is equal to 1 by z. Then we get y naught is equal to 1 by 4 of an 1 plus I. When you multiply both sides with 1 plus I by 1 minus I, then we get 4 into 1 minus I by 2. One side goes by 2. So y naught will be coming at 2 minus 2i. So it is coming outside the unit circle. So it will be satisfied in the option D. Now coming next question. The question is, for the function sin z by z cube of a complex value function z, the point z is equal to 0 is, you have to find whether it is a pole of order 3, 2 or 1, or it is not in a singularity. Okay, we given that sin z by z cube, right? By seeing this one, we can say that it is a pole of order 3. But by using the Taylor series and Lorentz series, we exactly find the singularity of it. Okay, we know that sin x is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial plus so on, we get it, right? So by using in a Lorentz series and Taylor series, we'll be expanding it. So it becomes 1 by z cube into z minus z cube by 3 factorial plus z power 5 by 5 factorial plus so on, we get it. When you multiply that, okay, with 1 by z cube, it becomes 1 by z square minus 1 by 3 factorial plus z square by 5 factorial plus so on, we get it, right? So in this particular series, we can see that there is only one term, right? 1 by z square. So it is nothing but a pole of order 2, right? So answer is option B. Now coming next question. The question is, if z is equal to x plus jy, where x and y are real, the value of IPA jz mod is how much we have to find. We know that z is equal to x plus jy, right? Which is equal to nothing but r into IPA I theta, right? Where r is equal to nothing but under root of x square plus y square, which is equal to mod z. So we can see that mod of r into IPA I theta is equal to nothing but mod z, which is equal to r, right? The general thing you have to know. Now you have to find the value of mod of IPA jz, which is equal to mod of IPA j into z. Z we are substituting it, x plus jy, which is equal to, it becomes IPA gx into IPA minus jy mod. If you see this term, okay, this term is r and this power term is I theta. So mod of this one is equal to nothing but r only. So r is nothing but IPA minus y. So answer option C. Now coming next question. The question is, the real part of an analytic function f of z, where z is equal to x plus iy, is given by IPA minus j cos x. The imaginary part of, okay, what they are saying that when if you consider f of z, which is equal to u plus iv. So the real value is given. You have to find the imaginary part, b value. So they're given that u is equal to e power minus y cos x, right? You have to find the value of v is how much. First, what you do is nothing but differentiate v with respect to x and y. So it becomes dv by dx into dx plus dv by dy into dy, right? So you have to know the CR equation, Cauchy-Riemann equation, given as du by dx is equal to dv by dy. The other one is du by dy is equal to minus of dv by dx, as the function is analytic function, right? So we can substitute here. It becomes minus of du by dy into dx plus du by dx into dy. So we're finding the value of du by dx and du by dy. So here we get du by dx is equal to what? We substitute here. If you differentiate with an x, then it becomes minus e power minus y sin x, right? And du by dy is equal to minus of e power minus y cos x. So substitute here, it becomes minus of minus e power minus y cos x dx plus du by dx is nothing but minus e power minus y sin x dy, right? Which is equal to nothing but dv, right? So just we'll be doing the integrations. In the integration, the particular value will not be considered the x terms, okay? So this one becomes 0, right? So we get v is equal to nothing but minus becomes plus, and we'll be integrating cos. So it becomes e power minus y integration upon a cos x dx. Cos x differentiated is nothing but sin x, so it becomes e power minus y sin x is nothing but v. So it will be satisfied in the equation option B. Now come next question. The question is the analytic function of a complex variable z is equal to x plus iy is expressed as f of z is equal to u plus iv, where I is nothing but root minus 1. If u is equal to xy and value of v, we have to find it out, where u and v are a function of x and y, right? So they're given that u is equal to 2xy, right? And we have to find the value of v. That's how much. Then what we do is now differentiate v with respect to x and y. So it becomes dv by dx into dx plus dv by dy into dy, right? For this one, you have to know the Cauchy-Riemann equation, as the function is analytic function. So it is not one du by dx is equal to dv by dy. The other one is du by dy is equal to minus of dv by dx. So on substituting, we get this one as nothing but minus of du by dy into dx plus du by dx into dy, right? So we'll be finding the value of du by dx, which is equal to nothing but just differentiate with this one with respect to x, it becomes 2y, and du by dy, which is equal to 2x. So we get nothing but minus of dy is 2x into dx plus here it becomes 2y into dy is nothing but dv. Now we'll be just integrating it, okay, each term. Here we should not contain the x term, but there are no x terms, so we have to consider this one also. So which is equal to minus 2 x square by 2 plus 2 into y square by 2 plus constant k value, which is nothing but v. So we get v is equal to nothing but minus x square plus y square plus constant term k. So it will get satisfied in the equation option C. Now come next question. The question is The analytic function f of z is equal to z minus 1 by z square plus 1, having singularity z. Okay, so they given that f of z is equal to z minus 1 by z square plus 1. Now you have to find the singularities, right? There's nothing but we'll be equating the denominator to 0. So it becomes z square plus 1 should be equal to 0. Then you get z is equal to nothing but plus or minus root minus 1, which is equal to plus or minus I. So singularities are nothing but plus or minus I. So it will going with an option D. Next question. The question is, can a circle mod of z minus 5 I is equal to the complex plane x5 when z is equal to x plus I y. The minimum distance from origin to the circle is. So what they are given is nothing but mod of z minus 5 plus 5y. Okay, is equal to 2. So we can see that center of a circle is equal to 5 plus 5y, right? And the radius of a circle is equal to 2, right? So if you draw in a graph here, there's a real part of an z, x. There's an imaginary part of an z, iy. It is centered at an 5 plus 5y, right? Now if you draw a straight line from origin to this particular point P, okay, now you have to find the minimum distance, right? So we have to find the value of O to Q. Okay, we have to find the value of O to Q. That's how much, right? Now we know that radius is 2, so P to Q is nothing but 2, right? And the distance from P to the point here, if you consider R point, is nothing but 5, right? Now from O to R also 5 only, right? So first we'll be finding out O to P, how much distance is there. It forms a triangle 90 degrees. So OP is equal to nothing but under root of PR square plus OR square, which is equal to under root of 5 square plus 5 square, which is equal to 5 root 2. So total distance we got OP is equal to nothing but 5 root 2, right? But we know that Q to P, the distance is nothing but 2 only. So we can find O to Q is equal to nothing but OP minus Q to P, right? Which is equal to 5 root 2 minus 2, right? So minimum distance is nothing but 5 root 2 minus 2. So answer option E. Now come to the question. The question is, the residue of the function f of z is equal to 1 by z minus 2 whole square, z plus 2 square at z is equal to 2s. Okay. Now we have to find the residue of this particular function. The general formula we know that residue of a function f of z as z tends to E is given as 1 by n minus 1 factorial into limit z tends to A d by dz of n minus 1, right? Differentiation into z minus A whole power n f of z, right? Now it be equating this particular function to f of z, which is equal to 1 by z minus 2 whole square, z plus 2 whole square. And you have to find the residue for z is equal to 2. So here A is nothing but 2. So it becomes residue of f of z for z tends to 2 is equal to z tends to 2 is nothing but z minus 2 whole square. So it becomes 1 by 2 minus 1 factorial into limit z tends to 2 d by dz into z minus 2 whole square into 1 by z minus 2 whole square into z plus 2 whole square, right? So just to solving it here it becomes 1 factorial, it is 1 here, so it becomes 1 into limit z tends to 2 and it becomes d by dz of these two get cancelled, 1 by z plus 2 whole square, right, which is equal to, it becomes limit z tends to 2. Find the differentiation of it, it becomes minus 2 by z plus 2 whole cube, right. So substitute 2 here, so it becomes minus 2 by 2 plus 2 whole cube, right. 2 plus 2 is nothing but 4, so it becomes minus 2 by 4 into 4 into 4, right. Now 2 goes by one side, it goes by 2 side, right. 4 4 is 16, 16 into 32, which is equal to minus 1 by 32. So answer is option A. Now coming to the next question. The question is, the residue of a complex function x of z is equal to 1 minus 2z by z into z minus 1 and z minus 2. At its poles are, okay. Now first we'll find the poles of it. Poles are nothing but, in the numerator we have z is equal to 0 and z is equal to 1 and z is equal to 2, right. So these are the poles and we have to find the residue for each pole, right. Now the function is given 1 minus 2z by z into z minus 1 into z minus 2, right. For residue of a function, we know the general formula, that residue of a function f of z for z tends to a is given as 1 by n minus 1 factorial into limit z tends to a d by dz n minus 1 times into z minus a whole power and f of z, right. Now we'll be substituting it for each pole and find the values of it, right. Now if you consider the first case, z is equal to 0, then n value, it's a power of 1, so we can see that n is equal to 1, right, and e value is nothing but 0 only, it is a pole, right. So the substitute it does nothing but residue of an f of z for z tends to e is equal to, becomes 1 by 1 minus 1 factorial into limit z tends to 0. Now 1 minus 1 it becomes 0, so no indefinite differentiation, so it becomes into z into 1 minus 2z by z into z minus 1 into z minus 2, right. Now these two get cancelled here, 0 factorial is nothing but 1, so it becomes 1 into, substitute the 0 in this particular function, so it becomes 1 divided by minus 1 into minus 2, which is equal to 1 by 2. So for z is equal to 0, we got the residue as 1 by 2. Now it substitute for z is equal to 1. Now for z is equal to 1, the n value is nothing but 1 and e value is nothing but 1, which is a pole only. So we get residue for z tends to 1, f of z is equal to 1 by 1 minus 1 factorial into limit z tends to 1. Now no need of doing differentiation, 1 minus 1 is 0, so it becomes z minus 1 into 1 minus 2z by z into z minus 1 into z minus 2, right. Now these two get cancelled. Now 0 factor is nothing but 1, so it becomes 1 into, substitute limits here, it becomes 1 minus 2 by 1 into 1 minus 2, right, which is equal to 1, right. So we get value as this one as 1 for z is equal to 1. Now we're finding for z is equal to 2. Now here also n is equal to 1 and A is nothing but 2. So residue for z tends to 2, f of z is equal to 1 by 1 minus 1 factorial into limit z tends to 2, and no need of doing differentiation. 1 minus 1 is 0, so it becomes z minus 2 into 1 minus 2z by z into z minus 1 into z minus 2, right? These two get cancelled, and 0 factor is 1, so it becomes 1 into, substitute 2 here, so it becomes 1 minus 22 4 by 2 into 2 minus 1, which is equal to, it becomes minus 3 by 2. So for this one we got as minus 3 by 2. So in the option, it will be satisfied in the option C. Answer is C. Next question. The question is, given x of z is equal to z by z minus a whole square, z is greater than a. The residue of x of z into z power n minus 1 and z is equal to a. For n greater than equal to 0 will be. Okay. Now given that x of z is equal to z by z minus a whole square. Right. Now they are asking the residue of z tends to a into x of z, z power n minus 1. Right. First rule is substituting it. Then we get residue z tends to a. We are substituting x of z. It becomes z by z minus a whole square into z power n minus 1, which is equal to residue z tends to a. It becomes z power n by z minus a whole square. Right. The general formula we know that residue z tends to a f of z is equal to 1 by n minus 1 factorial into limit z tends to a d by dz n minus 1 times of z minus a whole power n f of z. Right. Now when you equate both of them, we get that f of z is equal to z power n by z minus a whole square, and we get n is equal to nothing but 2. Right. So we just substitute it. We get 1 by 2 minus 1 whole factorial into limit z tends to a d by dz. As n is equal to, we have to differentiate one time into z minus a whole square into z power n by z minus a whole square. Right. Now these two get cancelled. Just differentiate this one. Here 1 factorial is nothing but 1. So it becomes 1 into limit z tends to a d by dz of z power n, which is equal to limit z tends to a. On differentiation, we get n into z power n minus 1, which is equal to n into a power n minus 1. Right. So answer is option D.